You know, when you think about a major breakthrough in engine technology, you probably picture some exotic supercar, right? Well, what if I told you that one of the most efficient gasoline engines ever made isn't in a Ferrari, but in a regular family car? Today, we're going under the hood to see how they did it.
Just look at that number, 39.8%. That means for every single drop of gas this engine uses, almost 40% of its energy gets turned into actual motion. Now, to put that into perspective, most engines are lucky to hit 25, maybe 30%. The rest, it's just wasted as heat. So a number like this, it's absolutely staggering.
So the obvious question is, how? How in the world does a normal engine pull that off? To find out, we're going to follow a team of engineers at the U.S. Environmental Protection Agency as they tear one of these things down piece by piece to unlock its secrets.
And let's be clear, this is not your average garage. We're inside the EPA's National Vehicle and Fuel Emissions Laboratory. This is a place where they have the tools to measure pretty much everything, right down to the microsecond, so they can test and benchmark the most advanced engines on the planet.
Their whole mission here is to do a really deep dive on this specific engine. It's Toyota's 2018 Dynamic Force engine. They want to create a complete performance map of it, to really understand the engineering magic that makes it so efficient.
And this is where the action happens. On the left, you see the clean schematic, the plan. On the right, you see the messy reality. The engineers hook the engine up to what's called a dynamometer. It's basically a treadmill for the engine, letting them measure its power and fuel use under every condition you can imagine.
Okay, so the first big secret to this engine's incredible efficiency is all about how it breathes. It uses a clever trick called the Atkinson cycle. But before the EPA team could even study it, they had to figure out how to measure it. See, to really understand the Atkinson cycle, you have to know exactly when the engine's valves are opening and closing. The problem is, all the old-school methods for doing that, well, they just don't work on a modern engine like this. They're clumsy, they're destructive, or you just can't get the data you need. So what they came up with was just brilliant. Instead of drilling holes in the engine, they pointed a super precise laser right at the top of the valve. By bouncing a little beam of light off it, they could measure its movement with incredible accuracy, all without leaving a single scratch on the engine. And here's the secret the laser revealed. This engine actually delays the closing of its intake valve. It leaves the door open just a crack to push a tiny bit of the air and fuel mixture back out. Now that sounds weird, I know, but it drastically cuts down on what are called pumping losses. Think of it as making the engine's breathing more effortless, which saves a ton of energy during normal everyday driving. All right, on to secret number 2, and this one sounds totally backwards. To make the engine more efficient, it actually pumps some of its own exhaust fumes right back into the cylinders to be burned a second time. It's a technology called cooled exhaust gas recirculation, or CEGR. The best way to think about it is like adding a calming agent to the fire inside the cylinder. The exhaust gas cools things down, which stops damaging engine knock and lets the engine run a much more efficient combustion cycle. Now, measuring how much exhaust was being recycled was another huge challenge. You can't just go online and buy a tool for that. So this just shows the ingenuity of the team. They had to design, engineer, and build their very own custom part, packed with sensors, just to get the data. And boy, did their custom tool pay off. This heat map shows what they found. The engine is using a massive amount of that recycled exhaust. At its peak, over 24% of everything going into the cylinder is old exhaust, and it does this right in the sweet spot for normal city and highway driving. So with all the data from the laser and their custom-made parts, the engineers could finally put all the puzzle pieces together. They were ready to create the full efficiency map and see what this engine was really capable of. And here it is. This is the money shot. This map shows the engine's sweet spot. That big red and yellow island in the middle is this huge operating range where the engine is over 38% efficient, peaking at that incredible 39.8%. It's not just efficient at one tiny point, it's efficient across a wide band of speeds that you actually use. So what does that actually mean for you at the gas pump? Well, the EPA plugged their data into a simulation and compared it to another really good engine from just 5 years earlier. In the same type of car, this Toyota engine gets almost 45 miles per gallon. That is a huge jump. And this super detailed map isn't just an academic exercise. It's a critical piece of the puzzle for the EPA. This data gets fed right into their simulation models, which helps them accurately predict the fuel economy and emissions of future cars and helps set standards for the whole industry. But here's where it gets really cool.
The EPA didn't just stop at understanding today's engine. They also looked at how this already amazing design could be pushed even further, using technology that's already available.
The key technology is something called cylinder deactivation. The idea is simple. When you're just cruising on the highway and don't need all 4 cylinders worth of power, the engine just temporarily shuts down 2 of them. It turns a 4-cylinder into a 2-cylinder on the fly to save fuel.
And this chart shows just how much that could help. Now, what's really interesting is that even on an engine like this one, which already uses that CEGR trick to be more efficient, adding cylinder deactivation still gives it another significant boost in fuel savings.
How significant? The EPA's analysis estimates that adding the most advanced version of this tech could cut this engine's fuel consumption and CO2 emissions by another 3.3%. And remember, that's a gain on top of an engine that's already at the top of its class.
All of this just makes you wonder, doesn't it? The gasoline engine has been around for over a century. You'd think we'd have figured out everything there is to know. But this whole project proves there are still brilliant engineers out there finding clever new ways to perfect the internal combustion engine. Its story might not be over just yet.